In the silence of space, one wrong move could cost a life. Up here, there is no air, no sound, no second chances. Yet astronauts drift fearlessly into the void, protected only by a suit. A creation so advanced, it is not just clothing. It is a personal spaceship. Every step outside Earth's atmosphere is a fight against the impossible. Temperatures swing from 200 degrees below zero to over 200 above. Invisible radiation fills the emptiness. And without pressure, the blood inside your veins could boil. But through all of this, a human body survives. Inside the armor of technology, called the spacesuit, a spacesuit must do what Earth itself does for us. It must give air to breathe, pressure to hold the body together, warmth against cold, and protection from sunlight so fierce it could blind. It must remove carbon dioxide, control humidity, and even handle waste. It is a miniature Earth, built around a human being. Without it, the vacuum of space would end life in seconds. The design of the modern suit began with fear. The fear of stepping into nothing. In the early days of space exploration, engineers knew that even a tiny leak could mean disaster. So they built layers, one after another, each layer designed for a single vital purpose. Inside, the astronaut wears a soft inner layer that touches the skin. It is like thermal underwear, woven with tiny tubes of water. These tubes circulate temperature-controlled liquid. They keep the astronaut from freezing or overheating. This system is called the liquid cooling and ventilation garment. Every drop of that water is recycled, cooled or warmed, depending on whether the astronaut faces the sun or the shadow. Over that inner layer comes the pressure bladder. It is made from synthetic rubber and urethane-coated nylon. It keeps air pressure constant around the body, simulating the same pressure we feel on Earth. Without that pressure, body fluids would begin to boil in the vacuum. Because that bladder cannot hold shape by itself, another layer is added. The restraint layer, made of Dacron. It stops the suit from ballooning like a bubble. Only then does the outer shell arrive. The white armor we see in every photo. Its job is protection. Protection from micrometeoroids that strike like bullets. Protection from radiation that burns. Protection from dust sharper than glass. Each piece of the suit is handcrafted, tested, and fitted to a single person. No two suits are the same. Every glove is molded to match the curve of an astronaut's hand. Every joint, shoulder ring, and wrist bearing must rotate smoothly, even in vacuum. Because out there, when repairing a satellite or walking on the moon, a stiff glove could be the difference between success and disaster. And then the helmet. A bubble of polycarbonate, strong enough to resist micrometeor impacts. The gold-tinted visor is not just for style. It blocks ultraviolet and infrared radiation from the sun. Without that golden layer, sunlight would scorch the eyes instantly. A ventilation system inside the helmet moves oxygen constantly. It prevents the visor from fogging. The communication system, microphones, and speakers are built right in. Because in the void of space, sound cannot travel. Every word is transmitted by radio. Attached to the back is the most vital component, the portable life support system, also known as the PLSS. This backpack is the heart of the suit. Inside it, oxygen tanks feed the astronaut's lungs. Carbon dioxide scrubbers clean the air again and again. Pumps drive cooling liquid through the tubes. Batteries supply power for hours. And if everything fails, a small emergency bottle gives a few extra minutes of life, a final breath before silence. Even the smallest detail has purpose. The gloves have heaters in the fingertips. The boots are designed to grip lunar dust. The layers of fabric can resist tiny space debris flying at 7 kilometers per second. Each zipper, connector, and seal is tested over and over. Because once the astronaut leaves the airlock, there is no repair, no backup, no help. The process of wearing the suit is a mission itself. It takes hours of preparation. The astronaut first puts on the cooling garment, then the pressure layer, then the communication cap, gloves, and boots. The helmet locks with a click. The life support pack seals in place. Oxygen begins to flow. The air pressure slowly rises to match Earth-like conditions. Every step is checked by engineers, every gauge read twice. Only then, with steady breath and calm heart, does the astronaut step into the void. Inside the suit, the sound changes. There is no wind, no echo, only the quiet hum of fans, the whisper of your own breath, and the steady rhythm of your heartbeat. Space feels infinite, yet you exist inside a tiny world of fabric and machinery. You can see Earth below, glowing blue and alive. You can see the moon ahead, gray and silent. Between them lies everything that defines human courage. The spacesuit transforms the impossible into the achievable. When Neil Armstrong stepped onto the moon in 1969, every movement was powered by that suit. It carried oxygen, regulated heat, and protected him from micrometeoroid impacts. The same technology has evolved, layer after layer, into today's suits aboard the International Space Station. Each generation becomes smarter, lighter, safer. But even after decades of innovation, the goal remains the same: survival. A balance between freedom and protection. Too stiff, and the astronaut cannot move. Too soft, and the pressure fails. Engineers fight this paradox with ingenious systems: metal joints, accordion-folded fabric, and carefully calculated tension cords. Every bend of the knee or elbow involves physics, chemistry, and design. Imagine floating above the Earth. Below you, continents drift under clouds. Around you, infinite blackness. Every movement pushes you forward gently. The suit keeps you alive, but also reminds you how fragile you are. One scratch, one puncture, one wrong move could cost a life. And yet, despite the danger, humans keep going. Further, braver, more determined. But if everything in space is constantly moving, then here's a question that shakes our very understanding of reality. If the Earth is spinning, if the moon is orbiting, if the sun is racing through the Milky Way, and the Milky Way itself is hurtling through the universe at unimaginable speed, then what exactly is still? What is the fixed point we compare everything to? Is there even such a thing as absolute rest? Science once believed there was. Long ago, scientists thought there must be something. An invisible substance filling all space called the ether. They believed light waves move through this ether, just like sound moves through air. But then came one experiment that changed everything. In 1887, Michelson and Morley tried to detect the ether. They used precise instruments to see if Earth's motion through this ether would change how light behaved. But their results shocked the world. They found nothing. No ether. No absolute rest. Light moved exactly the same, no matter which direction Earth was going. It was as if the universe whispered a secret. There is no stillness. Everything is relative. Years later, Albert Einstein took that whisper and turned it into a revolution. His theory of relativity said that motion depends on the observer. There is no universal center, no edge, no stationary point. Every motion is relative to something else. You could say the sun moves around you, or you move around the sun. And both would be right depending on your frame of reference. But this idea leads to something even stranger. If motion is relative, then time itself is relative. When you move faster, time slows down. When you approach the speed of light, time nearly stops. So the spinning of the universe isn't just about motion, it's about time. Space and reality twisting together in one cosmic dance. Now imagine this. As you sit still right now, you're actually moving faster than you could ever imagine. You're spinning with Earth at 1,600 kilometers per hour. You're orbiting the sun at 107,000 kilometers per hour. The sun is orbiting the Milky Way at 828,000 kilometers per hour. And the Milky Way itself? It's speeding through the universe at more than 2 million kilometers per hour. All while you think you're sitting still. Everything is in motion. Every atom inside you is vibrating. Every electron is spinning. Every galaxy is rotating. It's as if motion is the heartbeat of the universe. But here's where the mystery deepens. If everything is moving, galaxies, stars, planets, even the tiniest particles, then what is space moving through? What lies outside this cosmic motion? Is the universe itself moving? And if it is, what's beyond it? These are questions that even modern physics struggles to answer. Some scientists believe the universe is expanding into nothing, that nothing isn't even space, because space itself is what's expanding. Others suggest our universe could be one of many, a single bubble in a vast multiverse, where other universes drift and spin in their own directions. If that's true, then everything we know might just be one small wave in an infinite cosmic ocean. When you look up at the night sky, you're not just seeing stars, you're seeing time itself. You're seeing light that left those stars millions, sometimes billions of years ago, and while you gaze at them, they've already moved far away. Everything is changing. Everything is spinning. Nothing stays still. And maybe that's the beauty of it. Because if everything in the universe is moving, then so are we. Not just through space, but through time, through growth, through discovery. The universe spins, and so do our lives. And maybe, just maybe, that motion is what keeps everything alive. So next time you look at the stars, remember this. You're not standing on a still world watching them move. You're part of the same cosmic motion. You're spinning with them. You're traveling with them. You're one with the dance of the universe. Everything is in motion. Everything is spinning.